Hello everyone, welcome to Control Systems and Instrumentation lecture series. In today's video, we are going to learn about a very important sensing device widely used in instrumentation and mechanical engineering, the strain gauge. So here in this video, we'll cover what it is, how it works, types, construction, application, and real examples. So let's get started. Now, what is screw gauge? A screw gauge is a sensor that is used to measure strain. Okay, normally strain means the amount of deformation or stretching in an object. So, whenever a material is pulled or pressed, it changes its shapes. This changes, we'll be calling it as strain. And the strain gauge converts this into an electrical signal. Okay, so now here comes a question. Why do we need strain gauge? So this strain gauge is essential because mechanical parts deform under load. Stress analysis helps prevent failures. Accurate load and force measurements is needed in machines and it is used in structural health monitoring. So these screw gauges helps us to understand how much force and weight an object is experiencing. Okay, now we'll see the construction of strain guards. So, a typical strain guard has grit or foil pattern made of an alloy, and it has a backing material, and it is of thin insulating layer, and it is adhesive to stick the gauze to an object, and the lead wires for the electrical connection. The foil pattern, right? It's arranged in zigzag. You can see in this construction. It's and this is arranged in zigzag manner. And when an object is under measurement stretches, the foil stretches and the resistance get changed. And now we'll see how it works. The basic principle, working principle of strain gauge is very much simple. When a conductor is stretched or compressed, its electrical resistance changes. Okay. So the strain gauge uses this principle. Uh, Make a note of it when it is attached to surface. If the surface stretches, the resistance increases. If the surface compresses, the resistance decreases. This tiny change in resistance is converted into voltage. Using a circuit, usually we'll be using a Wheatstone bridge for this. Now we'll go with the application of strain gauges. Strain gauges are used in many industries. Some major applications we can say it as load cells for weight measurement, pressure sensor, torque sensors, bridge structural monitoring, robotic force sensing, automotive crash testing, and machine tool monitoring. So these are the application of strain gauge. And there are some types of strain gauges also. We have foil uh, strain gauge. It is most commonly used one and it has high accuracy. Next, we have wire strain gauge. It's an older type, less used in nowadays, and it's strong but it's of lower sensitive. And semiconductor strain gauge, it uses silicon, highly sensitive. So these are some types which can be noted. And next comes the factor affecting its performance. So first factor is temperature. Okay. Strain gauges normally can be affected by temperature changes. So we can use compensation methods to avoid it and materials used. Next comes the choice of substrate materials. It influences the gauge performance normally. Next comes calibration. So regular calibration is needed for this equipment. And what are the now we'll see advantages and disadvantages of strain guards. The advantages are it is of high accuracy, low cost, easy to install, and it works for very small strains, compatible with bridges and digital circuits, And the disadvantages here is it's sensitive to temperature, requires proper bonding, small resistance changes need amplification. So these are the limitations of strain gauges. So here was the roadmap how to learn these strain gauges. We have common types or foil, and we have just summarized it here. So that's all with this video. We'll see you in next session. Thank you.